Good evening. Can you hear me all right? I'm called Mumbles in the office, so I need to make sure that I speak out. My name is Prentis Hale, and along with Thomas Scher, I am one of the principals of Shed Architecture and Design. To my left is Alex Daisley with Hammer in Hand, who was the project superintendent for the Madrona Passive House. I'd like to say before we get going that there were many in my office that contributed to this project. And I would be remiss in not mentioning Alex Hale, no relation as far as we can tell, who was indispensable to this project. And without him, we wouldn't be looking at the finished product. And, of course, the builders. All right, well, let's get going. Madrona Passive House would not have been possible without Jay Blumenthal, an ex-Microsoft Excel program manager, bullet board member, local climate change leader, and paraglider extraordinaire whose ambitions took the project to new heights. For Shed, this would be the first project whose aim was higher than the Built Green checklist. To help guide us through this exciting but unsurveyed territory, we relied on the consulting and construction expertise of Hammer in Hand. Together, we set out to design a house for Jay's family that would set a high standard for energy performance and advance sustainable building in Seattle and the Northwest. In Jay's words, we wanted a house that pushes the edges a little bit, not the very bleeding edge of what is technically possible, no matter the cost, but on what's almost economically reasonable today and should be quite reasonable tomorrow. This was not a bootstrapping project. Although we did not set out to build a passive house, Jay's desire for an energy-efficient home whose performance could be quantified during the design phase and measured post-occupancy made Passive House the logical choice. The project is located on a cul-de-sac in the Madrona neighborhood on a steep slope lot with territorial views of Lake Washington and the Cascade Range. Among the long list of site challenges that needed to be addressed was the balance between opening the house to the views east while creating a buffer to the south. In short, there was tension between the need to maximize solar gains while maintaining privacy from the well-traveled street on the south side of the property. We achieved a balance through comprehensive design analysis with Dan Whitmore of Hammer in Hand. The PHP Dashboard on the left is where the project ended up. Projected space heating demand of 3.51 kBTUs per square foot per year, 0.32 air changes per hour, primary energy demand of 34.7 BTUs per square foot per year. All of these metrics are well below the Passive House standard. The dashboard also shows the type of data that was evaluated, from wall assemblies to window to floor area ratios to the analysis of heat losses and gains. To use a builder's term, the dashboard was a story pole that guided the project and left an imprint on the final design. The top two slides illustrate the refinements that were made to the orientation and size of south-facing windows. The bottom two slides show how the east facade was transformed to control heat gain and to reduce thermal bridging by replacing the steel brace frame with wood shear walls. I would be lying if I said that I did not have a twinge of regret when I see the image of the original ribbon of glass. But I'm also proud that we made decisions that realized big picture project objectives. I will now hand over the mic to Alex, who will talk about the details.
Hi, everybody. So one of our goals with the Madrona Passive House was to simplify the wall assembly. We're drawing on our experience with previous Hammer in Hand Passive House projects, such as Glasswood. What you see here, we had up to 10 layers, and with Pumpkin Ridge, where we reduced it to 7. With Madrona, we managed to actually get it down to 6. And with that, the same approach is now being utilized in the Wallingford Passive House, currently under construction, and will be again utilized in an upcoming project in the Issaquah Highlands. Managing heat, air, and moisture, or as we call it, HAM. As with any high-performance wall assembly, the challenge is managing the transference of heat, air, and moisture. Here we have the zip wall sheathing acting as our air barrier. One of the advantages of using zip wall, it gives us the air barrier as well as our WRB being integrated into that sheathing material. For heat, we have the 3.5 inches of mineral wool insulation, and then the 5.5 inches of interior, fiberglass insulation blown into the interior framing walls. This gave us a total R value of R37. The FSC siding provides our preliminary barrier to bulk water, while the Roxwool mineral wool being hydrophobic itself gives us a secondary water barrier while remaining vapor open, which is allowing it to dry to the exterior. Any water that finds its way behind the siding layer will drain freely due to our robust 1.5 inch rain screen batten system, which in turn provides superior ventilation behind the siding, promoting the desired drying effect. This assembly is a vapor open in both directions. The mineral wool facilitates drying outward by its vapor open nature, while the zip wool sheathing is a vapor retarder and decreases the movement of interior air into the assembly. So Passive House is a path to net zero. So due to the home's advanced building envelope and the Passive House strategies implemented throughout the construction, we have reduced the heating and cooling demand for this home by 90%. Clearly, this reduced energy need offered an opportunity to offset all of the home's energy needs by utilizing a larger PV solar array. This was not necessarily the initial intent. However, once Jabe saw the projected energy needs for the home, and from our modeling numbers, he decided that it was a target worth pushing for and went forward with a 9.8 kilowatt solar array system. Of course, there are more efficient ways to generate solar energy than from one residential rooftop installation, such as large-scale commercial rooftop opportunities. But we and Jabe agree that right now the market needs more solar deployed, and the more visible, the better to promote it. With the monitoring equipment installed in this home, we have no doubt that Jabe and his family will be able to manage their consumption and adjust behavior as needed to achieve that net zero target, while also enjoying the benefits of a very comfortable and efficient home. Is it possible to make every new house a passive house? We think so. And we also think it's the right thing to do. Many other developed countries have implemented Passive House as their current building code and energy performance target. And we also see that our very own Department of Energy recognizes that as a building strategy, Passive House blows conventional and even Energy Star rated homes out of the water when it comes to either efficiency, durability, or comfort, which should be our priority as we build for the future. I'll hand it back to you, Chris.
Designing for your client is a self-evident statement for a service profession, or it should be. Shed strives to make beautiful, livable spaces that are responsive to our clients' needs and desires. We want to design spaces that our clients enjoy spending time in with their family, socializing with friends, working, relaxing, simply being at home. We also want to make well-designed houses that are sensible to build, durable, and efficient to use over the long haul. In the past, we might have compromised performance for design, specifying windows for their mullion size instead of U-value, or tolerating a little thermal bridging here and there. Madrona Passive House demonstrated that this position is no longer a viable one. In this project, our highest design objectives also exceeded the highest performance standard. Design and performance go hand in hand, and while not every project will be a passive house, they should be pushed as far as they can go. And we should help our clients get there. The statement that new houses should set new standards should also be self-evident. New single-family houses are inherently unsustainable. And if we choose to design and build them, then we should make them as energy and resource efficient as possible. We should also help make sustainable design methods the norm. To quote Jabe again, If the house costs 10, 15, or even 20% more to build in a climate-friendly way, then it's reasonable for others with some extra money to replicate, especially if the 10th or 20th such house in Seattle costs only a few percent more. We want our house to be part of driving these technologies and building practices to be mainstream. Madrona Passive House will be certified Passive House and DOE Zero Energy Ready Home in early 2016, and it has been registered with the Living Building Challenge's Net Zero Energy Building Program. You might have noticed that the built house looks very similar to the rendering that started this presentation, albeit without landscaping and a flock of seagulls. In 1 year, we expect the performance of the house to meet or exceed the PHP Dashboard and be net zero or positive. We also expect Jabe and family to enjoy living here for a very long time. In the meantime, Shed and Hammer in Hand will continue to contribute to sustainable building and design in Seattle.